Hi everyone! In this monetary tutorial, I'm going to show you why we should not use float or double if we need exact answers, such as financial calculations. This example comes from the Effective Java book by Joshua Bloch and illustrates the need to know the library of the programming language we use to be a competent programmer. Suppose you want to spend $1 to buy a row of candies priced at 10 cents, 20 cents, 30 cents, and so on. You start buying one candy that costs 10 cents, and then one that costs 20 cents, 30 cents, until you cannot afford the next candy on the shelf. We want to write a program to calculate the number of candies we can buy and how much change we get. Let's start by writing code that uses double, as it's natural to use this data type to store floating point numbers. We declare a variable funds and initialize it with $1 to represent the amount of money we have. We also declare an initialize item spot to keep track of the number of candies we can buy. Then, we construct a for loop to calculate the number of candies we can purchase and the remaining money at the end of these transactions. We start by buying the cheapest candy priced at 10 cents, 20 cents, 30 cents, until we cannot afford the next candy. If you solve the problem by hand, the correct answers would be 4 candy spots and no change. However, when we run this program, the output is not as expected due to the inability of the computers to represent floating point numbers such as 0.10 exactly. How do we solve this problem correctly? There are two options to solve this problem. First, you can use int or long, depending on the amount of money involved in the questions. Perform the calculations in cents instead of dollars amount, and keep track of the decimal point yourself. Using a primitive data type such as int or long is very efficient. But you have to keep track of the decimal point, and there is a limit on how big the numbers that can be stored using int or long. In this example, we can simply use int to perform the calculations correctly. We just need to change the code a little bit to convert everything into cents. As expected, the program now produces the correct answers. If you want to show the output as dollars amount, you'll need to convert the remaining money from cents into dollars correctly, including the decimal point. In this demo, I'll simply change the output message to indicate the change is in cents. The second approach is to use Big Decimal. Big Decimal is an object type and comes with costs. To use Big Decimal, we need to import the Big Decimal class that is part of the java.math package. As you type Big Decimal for the first time in your code, IntelliJ will add the import statement automatically. In this case, we create a Big Decimal object to hold a constant value of 10 cents. Object types in general are slower than primitive types. We also cannot use the plus or minus signs to do the calculations as usual. Instead, we must call the corresponding methods such as add and subtract. We can use the compare2 method to compare two big decimal objects. The compare2 method returns a negative value if the first object, in this case funds, is less than the second object, which is price. It returns 0 if funds is equal to price, and it returns a positive value if funds is greater than price. When you run this program, you get the expected output, which is 4 candies and $0 change. You can see that in this example, the algorithm remains the same. There is nothing wrong with the algorithm. The first code doesn't produce the correct answers due to the use of double when exact solutions are required. The advantages of using Big Decimal are that it can represent any values, no matter how big they are, and that it offers many convenient methods. For example, you can specify exactly how you want to round the numbers, which sometimes is required by law in business or financial calculations. In summary, you should avoid using float or double to perform calculations where exact answers are required. Instead, you can use int or long and keep track of the decimal point yourself, or use Big Decimal to do the calculations. This example illustrates the importance of getting familiar with the programming language we use and is part of the best practices in Java programming.